Welcome to the Explainer. Okay, let's just dive right in. Because today we are unraveling a biological mystery that literally happens in every single gym, living room, and calisthenics park around the world. We're looking at the true science of muscle fatigue. And we're treating this like a biological wound unit today. Why? Well, because the explanations most of us have been fed about why our muscles just give out. They're actually missing the true culprit entirely. We're going to look at exactly what happens on a microscopic level when you push your body to the absolute limit using some really clear evidence from our source material today. To set the scene, picture this classic scenario. You're doing push-ups. You are absolutely crushing those first few reps. You feel strong. You feel totally invincible. But then somewhere around rep 12, your muscles basically throw in the towel. They completely quit on you and essentially just say, "Nah, we're done here." You try to push up, but your arms simply refuse to budge. We have all been there, right? Staring at the floor, wondering what on earth just happened to our strength, which brings us to a pretty fascinating question. Are your muscles just being dramatic? Or is there actual science, like a sneaky culprit, behind this sudden betrayal? Most people just jump straight to blaming lactic acid, or they assume they've completely run out of energy. It really feels like the tank is totally empty. But to solve this workout crime scene, we first need to clear the names of the usual suspects. And this is where we get to shatter what most of us were taught in high school biology. Let's look at the myth versus the reality here. The myth is that your ATP, your energy, runs out, and that lactate is just this toxic waste product building up. But the reality? Even when your muscles feel absolutely destroyed, they're actually still cranking out more ATP, like little microscopic energy factories. You haven't run out of fuel, and that lactate everyone loves to blame? Plot twist, it's not waste at all. Actually, scratch that. It's a powerful anaerobic fuel source that your body actively uses for energy. The reason it gets a bad rap is just that less athletic people use it less efficiently, so it builds up, and that led early scientists to mistakenly think it was just waste. Fit people actually burn through that lactate incredibly efficiently as fuel. So if it's not a lack of ATP and it's not a buildup of toxic waste, what is actually happening? Let's zoom in on the actual microscopic scene of the crime. Think of movement like your brain trying to send a text message to your muscles. Your brain sends these signals in fractions of a second through cells called motor neurons. But here's the kicker. The motor neuron and the muscle cell, they don't actually touch. They're separated by a tiny, tiny gap. On one side of this gap, the motor neuron is fully loaded up with a neurotransmitter called acetylcholine. On the other side, your muscle cell is surrounded by charged particles called ions. You've got potassium just chilling on the inside of the cell and sodium partying on the outside. So let's walk through how a healthy muscle actually fires. When your brain decides it's time to flex, the motor neuron releases that acetylcholine into the gap. That essentially tells the muscle cell membrane to open its doors. Instantly, sodium rushes in and potassium flows out. This massive trade-off stimulates a flood of stored calcium, and this calcium is absolutely crucial because it lets proteins inside your muscle lock together and literally pull toward each other. That right there, that is your actual muscle contraction. Finally, ATP provides the energy for this pulling action, and then it acts as the cleanup crew, pumping those ions right back to where they belong so the muscle can fire all over again. Now, all of those rushing ions we just talked about, that creates an action potential. Simply put, that's just fancy scientific talk for an electrical signal that tells your muscle to do something. And I really love the analogy provided by our source for this. This electrical signal spreads through the muscle cell like gossip in a small town. It moves incredibly fast, making absolutely sure the entire muscle gets the message to contract simultaneously. But here is where the plot twists. We know that unlike you last weekend, these ions usually know when to stop partying and get back to work under normal circumstances. However, every single time your muscles contracts, ATP gets used, lactate gets generated, and most importantly, those partying potassium, sodium, and calcium ions start to slowly drift away from the muscle cell membrane. After repeated contractions, they drift further and further away from the scene of the action, meaning the true villain behind your muscle fatigue is ion depletion. Because those ions have drifted away, there simply aren't enough of them around the muscle cell membrane to reset the system properly. Without that reset, an action potential literally cannot be generated. And if there's no action potential, your muscles lose the ability to receive instructions from the brain. Your brain is aggressively hitting send on that text message to flex, but the muscle has zero cell service. Your muscles didn't run out of fuel. They just went completely deaf to your brain's commands. It's kind of like you when someone at the gym tries to give you unsolicited advice on your form. You just stop receiving the instructions. So how do we actually fix this? Well, if you want your muscles to get better at this whole ion management game, you need to train them consistently. Our source specifically recommends jump rope training, calling it absolute perfect pairing for calisthenics or strength routines. In fact, they highlight a system called cross rope, basically describing it as ion depletion training without the joint destruction. Here's how that works. Using a light rope trains your fast-twitch muscle fibers to be much more efficient with their ions. Then swapping to a heavy rope forces your slow-twitch fibers to work even harder. You're actively teaching your muscle cells to be way less dramatic about managing their ions. And as a fun aside, the source notes that if you live in a tiny shoebox apartment, they actually make a ropeless version. So you won't absolutely destroy your ceiling fan. They even included a promo code GRABGEAR for 15% off if you want to try the whole shebang out for 60 days. But whether you jump rope or lift heavy weights, we finally arrive at the resolution of our biological mystery. Rest those depleted ions. They aren't gone forever. Your body has plenty of them floating around elsewhere. They just need a little time to get back to the tiny gap where the action is. This is exactly why resting between sets works so well. When you pause, ions flow back and the fatigue fades. And here is the really motivating part. The more regularly you exercise, the longer it takes for ion depletion to happen in the first place. Stronger people need fewer nerve signal cycles to do the exact same movement. Fewer cycles means slower depletion, so you can keep going much, much longer. Plus, bigger muscles come with bigger ATP stores and significantly better waste management systems. It's a win-win. Now, we have all heard this classic quote screamed across a weight room: "Pain is just weakness leaving the body." Well, armed with the actual science of muscle fatigue, we can officially debunk this. The next time someone drops this motivational gem on you, you'll know that technically it is completely wrong. It's actually just ions leaving the building. Of course, pain is just ions drifting away from your muscle cell membrane doesn't sound nearly as cool on a gym t-shirt. But scientifically, it's the absolute truth, which leaves us with a final thought to ponder as we wrap up this explainer. Knowing the true biology of fatigue, how will you change your training and rest routines to keep those ions firing? Now that you know you aren't just magically out of gas, but rather navigating a microscopic cellular reset, maybe you'll respect those rest periods a bit more. Maybe you'll focus on efficiency training, like the jump rope methods we talked about, to manage those ions better. The mystery is solved, the science is crystal clear, and the rest is completely up to you. Keep learning, Keep pushing, and I will catch you in the next explainer.